Howdy guys, Jimmy Song here. Welcome to another episode of Bitcoin Tech Talk Q&A. I do this every Monday as a way to sort of look over what's happened in the past week and talk about some of the interesting stories that I found from a technical perspective. Anyway, let's get straight to it. I do want to pop out chat this time so I can at least see what's going on. All right. So chat will be right over here. And let me go share my screen so you guys can see everything. Application window, there we go. All right, so if you are not subscribed, this is my Tech Talk newsletter, and this is where I, send it out every Monday morning, and you can take a look at all of the stories. It has a link to some of the videos I make during the week, and of course, a link to my book and my seminar if you are interested in those. Anyway, this is all available. It's on all in the show notes. You can sign up for the newsletter using the newsletter link. You can buy the book. You can apply for my seminar. You can look at my Twitter. You can read my Medium. You can look at my GitHub. Lots of things on my in the show notes there. Anyway, let's take a look at some of the stories. All right. So first one is the private key management evolution. This is a nice article written by Elena Veronova. Anyway, she works for Casa, and she goes through a lot of like where we've come from and where we're going. So in the very beginning, it talks about private keys and how they were secured and so on. Very good article if you're not familiar with the history of sort of like the privacy key security that was required way back when and up to today. So, Bitcoin started with non-deterministic wallets. That is, you had to save a private key each on its own. And that required, like Bitcoin paper wallets and things like that. And it only had a single address and a single private key. And there were a lot of different iterations of that, including Cassatius coins and this thing called Piper, which essentially stored that single private key under a tamper evidence sticker or would print it out as part of that machine Piper had. And then came deterministic wallets. Deterministic wallets, started with Electrum and Armory, and basically you save one seed and that would generate lots of private keys. And then that went toward, and then the next step was hierarchical deterministic wallets, or BIP32 wallets, which is probably what most of you use. And that allowed layers and organization around the deterministic wallet, which was a major innovation. There was also the addition of the mnemonic seed, which is what most Trezor and Ledger wallet people are very familiar with. And of course, that led to hardware wallets, Trezor, Ledger, and KeepKey, and many others. Later on, there were multi-sig wallets. Multi-sig's been around a while, but something that was a little more usable came in. And of course, there's now seedless multi-sig with Casa Keymaster, which is like what she's working on now. So good article to view sort of the history of like how private keys have evolved and where they're going. So good article to take a look at. Please take a look. All right, next one is an economics article, Bitcoin winner takes most or winner takes all. And it's talking about, sort of the monetary properties. A lot of people tend to think about Bitcoin from a very technical perspective. This one's a little more monetary, and I think that's the right lens through which to view Bitcoin. And it goes through, what currencies are, how many there are right now, and what the world was like before Bitcoin entered the picture, and how Bitcoin rose up. And there's a part 2 coming, and there's glass beads, rhinestones, all that fun stuff. If you haven't read the Bitcoin Standard, I totally encourage you to read it. But this it gives you a very brief overview of a lot of that too. All right, next article. This scaling tech could let you sync Bitcoin straight from your phone. And this is based on something called Utrexo. And it's from Taj Dryja. Taj is most well known for writing the Lightning white paper with Joseph Poon. He works at MIT DCI, and he's basically made this argument that you could store the UTXO set in a compact form and allow it to be existent on your phone. So you can run a full node from your phone, which would be amazing. I'd love to see more details on this, but the idea seems sound. Basically, you just keep track of the UTXO set, which I think is under 8 gigabytes right now, as opposed to the full blockchain, which is 200 gigabytes plus. And that's a big deal. That's something that your phone can pretty much handle. I don't know. Maybe your phone only has like 8 gigabytes of memory on it. But most phones come with 16, 32, 64, 128 gigabytes. So that's within the realm of possibility. And at that point, if you want all of the benefits of running a full node and not having to trust people, this would totally make sense to do. But it's probably some time away. But Utrexo is a very good idea and something to think about, and especially important for stuff like Lightning. And who knows? You might be running a full node on your phone along with Lightning at the same time in order to do transactions. That would obviate the need for something like Neutrino, but we'll see. We'll see. Depends on your use case and things like that. Speaking of Lightning, there is Thor Lightning channel opening service, something that I covered very briefly with Tone on his show. But this is a Lightning channel. Like, you open apparently an empty channel, so you don't give. They open a channel with you for a certain amount of money, and then you can refill that channel by giving them money, and then they'll send you that so you can refill other channels that you might have open. So it's a nice idea, definitely worth exploring and things like that. So that's Thor. Lightning Network enables Unicast transactions in Bitcoin. Lightning is Bitcoin's TCP IP stack. This is a very interesting argument about how Lightning is really at the base layer of a lot of different possibilities. This is the TCP IP stack, is what it's saying. And it's unicast. It's not broadcast to everybody. And that's the key distinction here. And this is something that I pointed out in the past. When you send a Bitcoin transaction, you are broadcasting to anybody and everybody that you're connected to on the network. And the idea is so that the transaction gets transmitted everywhere so that a miner will include it. So you kind of need a miner to be incentivized to do it. With a unicast model, you're only sending to the person that that people that need to know about it, right? Nodes on the network that need to know about it. So as Charlie Lee says, this is more in line with a peer-to-peer network than sort of like a gossip broadcast network that on-chain stuff is. And that's what this article goes into, and some of the implications. I encourage you guys to read it. Very interesting stuff. Let's take a look at the next one. Bias nonsense. Lattice attacks against weak ECDSA signatures in cryptocurrencies. This is a paper on a particular type of attack called the lattice attack. And it depends on sort of bias in the K value. So anytime you do any sort of signature, there's a K value that has to be random. And this is what's called a nonce. And nonce stands for number used only once. And it really should be only used once. If you use it more than once, then you are going to reveal your private key. So it's very important that this has entropy. And what this paper points out is that it can't even be biased in a certain direction. You can't have somebody be you can't choose that K so that it's always the first bit always starts with a 1 or something like that. That gives the attacker information about your private key. And this is a particular way to attack and try to recover your private key from a bunch of signatures using certain biasing methods. So very good paper. It's a really it's a little technical, but these are the things that you have to worry about when you're a developer. Is my K value random enough? Now, if you're using something like RFC 6959, this is called the deterministic K value. It shouldn't matter because that I think that's provably sufficiently random. But if you're using some other sort of K value, this might be something that you have to worry about. All right, so that was interesting. Here's another article that I talked about with Tone a little bit, but in case you missed it, this is Gate.io. Their research team realized that they were 51% attacked on Ethereum Classic. Essentially, what the attackers did was they did a reorg and did a double spend to Gate.io, and it looks like Gate.io lost a bunch of money. Well, a bunch of Ethereum Classic tokens, and it says here 54,200 Ethereum Classic. I believe Yobit had somewhere around 100,000 Ethereum Classic as well. So bunch of exchanges with Yobit, and those are the exchanges that hackers are likely to go for, because if you have AML KYC, then as soon as you withdraw, people are going to know who you are. So, so that's kind of the idea there. We'll see what happens, with other coins. I do think that Ethereum Classic was particularly vulnerable, though, because they had, their whole thing was, well, Ethereum is going to make this arbitrary rule. We're going to continue down this sort of purist path of not interfering with whatever the market does. That's come back to bite them a little bit, because they're second on the totem pole on their proof of work hash function, and that means that they can get attacked, and they're not going to roll things back because, well, I think their development has slowed down significantly, but also because that's part of their calling card, is that they're not going to interfere with whatever the market does. So in a sense, this what kind of led to their downfall a little bit. They're not centralized enough. It's kind of a scary idea. If you're not Bitcoin and you're not centralized, you're probably going to get attacked. So this is, it's kind of sad there. All right, another paper, first look at crypto mining malware ecosystem, a decade of unrestricted wealth. So this is an interesting paper, and let's see, how do we get to the PDF? Oh yeah, there we go. If we look at the PDF, this is all about like malware that mines like Monero on your browser or something like that. And they come up with some interesting statistics. It turns out something like 5% of all Monero has been mined by malware. Kind of crazy. Like, that's an interesting conclusion. They come up with all sorts of analyses. Interesting paper in that regard, and like where crypto mining hardware or crypto mining is going. That said, it's come to the point where if these altcoins stay at a high enough market cap, I think this sort of thing will continue to happen, and people will get their computers hijacked to some degree through malware. Botnets are very relatively inexpensive on the darknet markets, from what I understand, and this is a way to take advantage of it and monetize it. This a path of monetization for those guys. In a sense, like a lot of these coins have done ASIC resistance, but by adding ASIC resistance, you're just making it more profitable for all these malware writers. So in my personal opinion, ASICs are way better, and doing ASIC resistance is sort of like a fool's errand, because it's a game of whack-a-mole. All right. Last story is ASICs at 51% achieving mining dominance, how cost advantage drives centralization. So this is an interesting article. It's much more about AMD and NVIDIA with respect to Ethereum and their proof of work. And this is, their speculation that the calls to change proof of work on Ethereum is driven by somebody that really wants to do most of the mining, specifically Core Scientific, who has raised $100 million. And they are probably, the article speculates that they've probably got an alliance with NVIDIA or AMD to get direct access to a lot of their GPUs. And it's got, ex-Microsoft talent, so they do have the contacts to do it. What I didn't know from this article was that really AMD and NVIDIA, they have distributors, and they like it costs them like $150 to make a GPU, or I mean graphics processor, and basically they sell it to a distributor and mark it up to like $400. So they get a nice gross margin of something like 65%, and then the distributor will put it on a card and everything, and sell it for $450 and make like $50 a card. What they're saying in this article is, nobody, no mining manufacturer or anyone involved with mining really has that distributor relationship where they can get it for $400 and undercut everybody. They're speculating that this may be the case with new players that are coming into the market. So really interesting article. I encourage you guys to look at it. It's always a fun read to think about all of that stuff. Anyway, that is about it for the articles. Let me stop screen share. Let's take a look and see if there are any interesting questions in the chat. How to open port on Bitcoin Core to connect to a peer. You don't have to if you're doing outbound connections. You just connect to them straight. But if you are allowing inbound connections, you need to open a hole in your router, basically, to your server. I think if there was UPnP, that would be easier, but I'm not sure if that's the case here. All right, how do you get a real full Bitcoin Core valid node with more connections to peer on Windows in order to really help the network? Well, really, you're helping yourself when you're running a full node. It's so that you don't have to rely on anybody else to validate things, or if they start going on some weird software or something like that. That it's more for you, and that's at least why I run a full node. It's so that I can validate stuff for myself and not have to trust somebody. That's really the idea. You are, of course, helping the network by validating it yourself and sort of creating some economic heft, as like adding some economic adding your economic weight to what you validate. But really, it's more for you, right? Like if this node is yours, then you can trust it because you built it yourself. But if you're trusting somebody else, that's something else. All right. So Nick Salvo, do you think he could be Satoshi? Possibly. Jimmy, that refers to the K value of the signature. Yes, it is. Why not? He specifies. All right. If you have at least 2 private keys on a 2 of 3 multi-sig wallet, can you import that multi-sig address into your Core wallet? I believe so. You can at least watch it. As far as signing and things like that, that gets a little tricky. Although there's a BIP out for partially signed transaction format, and you might be able to import that eventually. Do you think it will once be possible to get Bitcoin directly on Lightning Network without any on-chain transaction? So through an ATM. Yeah, I mean, isn't that the whole point of a Lightning Network? If you have a channel open, then there's no on-chain evidence of what that transaction that you did, other than the settlement transaction. So that's the idea. All right. Anyway, that's about it. I think the show is a little shorter than I thought it would be. It's been about 20 minutes. Yeah, I do have Bitcoin related business ideas, but maybe not now is not the right time. I mean, I used to have a whole talk on like 5 free business ideas. I honestly, Casa was one of them. It was I want a hardware multi-sig wallet as a custody solution because that's basically what it should be. I didn't think it was that hard. I think another one was like some sort of messaging app slash wallet. So think of it as like Signal or Telegram, but being able to transfer Bitcoin via Lightning on some sort of a messaging app. I mean, I would certainly use it. It'd be basically kind of like WeChat in China, except you can use Bitcoin as the thing that's transferred back and forth, and you can use Lightning. It'd be instantaneous. It'd be really fast, and it could. I mean, that certainly has a significant amount of potential. Yeah, a lot of other ideas I had. I can go look up that talk some point. Yeah, it's been a while though, so I don't remember all of those. Anyway, hope that helps you. I think I'm gonna have to go and do a few other things. Copy edits for my book came in, so I have to go review all of those and you know, go. I think I did the first 2 chapters last night. I think I have like 12 more chapters of copy edits to go through. So a lot of different things to do. Anyway, hope that helps you. This song is done.